Okay, students, let's go over your first practice test. In problems 1 through 3, we're trying to determine if these equations are lines or not a line. And if they are a line, what type of line are they? Horizontal, vertical, or oblique? As you see right here in 1, 2, and 3. We did plenty of these in class. Okay, so you need to remember that in order for it to be a line, the exponents on the variables must be 1 in the numerator. If I have both an x and a y with a 1 in the numerator, then it's oblique, which I have in number 1. Remember, this one specifically says 1, this one doesn't. We know it's a 1 there. If it doesn't say anything, it's a 1. Okay, so that's automatically oblique. Number 2, we have the same situation again. I look at the variables. That's a 1 and that's a 1. So I have both an x and y in it, so it's oblique. If, for example, this was the 0 power, okay, then y to the 0 power is 1, and then negative 1 or negative 6 times 1 is negative 6, and I just add that across, and I get x equals a number. X equals a number would be a vertical line, versus if I had this as the 0, then I have negative 8 there. Move that across, I get y equals a number, and y is a horizontal line. Okay, so I'll review. And then lastly, I'm looking here, I don't just focus on this 1 here because this x is in the denominator. I cannot have an x or y in the denominator. Okay, since this is a positive 1, it stays there. If that was a negative 1 there, that would make it move up to the numerator, and then it would be a line, because here I have y to the 0, so it's just 1. And if it was negative 1 there, it'd move up, and I have 4x plus 7. And so x equals a number is a vertical line. But since this is in this situation right here, I have x in the denominator. Can't have that. So therefore, it is not a line, number 4. All right. Number 4, what's the degree of the polynomial? I look at the highest exponent on the variables. Notice I said on the variable or variables. 8 is not a variable, so I don't look at that 8 right there. Okay, it's not a variable. So this degree is 2, this degree is 4, this degree is 3, and this degree is 4. So the highest one is 4. So the degree is 4. Then it says write it in standard form. Standard form means from highest degree down. Well, since I have 2 degree 4s, I have to put those together. So negative 9 and negative 8 is negative 17, x to the 4th. There's only 1 cubed. Negative times negative is positive, so it's plus 3x cubed. There's only 1 x squared, so minus 3x squared. And then minus 8 to the 8th. The constant goes last. You do not have to multiply or put on a calculator 8 to the 8th power. You can just leave it written like that. That's fine. The point is that you know to go highest degree down and to combine like terms if you can. All right, do it again. This time we have more than 1 variable in each term. So I have to look at it here. Here I have a total of 7. Here I have a total of 7. Again, I'm only looking at the exponents on the variables. And here I have degree 2. So the highest degree 7. But these are not like terms because that's x to the 4th and that's x cubed. So I cannot put those together. Okay, so since they're both x to the 7th, the order doesn't matter. Usually you'll put the x first and the highest degree first. That's x to the 4th. That's x cubed. That's why I put it in that order. Okay, so both degree 7s on these first 2 terms. Remember, terms are separated by plus or minus signs. So we have 3 terms here. Okay, so both of these are degree 7, and this is degree 2, goes last for standard form. Okay, number 6, combine like terms. So again, I'm just looking for the ones that have like terms. So there's an x squared, there's an x squared. And negative times negative is positive, so 4 minus 8 is negative 4x squared. Then I go down to degree 1. That was the highest degree 2. Now I go down to my degree 1s. There's a degree 1, there's a degree 1. So minus 8 and minus 3 is minus 11x, combining like terms. You only add their coefficients together. The variable and the exponent does not change when you are adding. Only in multiplication does the exponent change. All right, and so there's my degree ones, and now I'm down to my constants. I have a negative 4 there and a positive 5 there. 5 minus 4 is positive 1. Okay, so there's your answer, combining like terms. Do it again now. Again, I need to distribute this first, though, into both of these. So I have an 8x to the fourth and a minus 6x to the fourth. Remember, I only deal with their their coefficients. So 8 minus 6 is 2x to the fourth. The variable does not change. The exponent does not change when you're dealing with adding or subtracting like terms. Now I have a 4x there. There is no x's in the second one, so I just write down plus 4x. And then I have a negative 6 times a negative 4 is positive 24. So there's that answer. You got to memorize these rules. You taught them in 7th and or 8th grade. Okay. All right, multiplying polynomials. So multiplying polynomials, now we do add their exponents. We're multiplying this time. So again, 2x, I'm distributing through there. That's a 1x, and there an x to the first, x to the first. So I add their exponents. I have 2 times 1 for my coefficients is 2. X times x is x squared. Then I have 2x times negative 3. Do not forget the sign with it. So that's negative 6x. Okay, do it a couple more times. Distributing this through. So 5 times 1 is 5. I have 5x's there and 6x's there for a total of 11. Multiply it through that one. That's 5 times 1 is 5 again. And then 5x's and 3x's is 8x's. And then to the last one, 5 times negative 2 is negative 10. And then here I have 5x's and 1x is 6x's. Okay, and there's your answer. Distributive property. When you multiply variables, remember these are called bases, like bases together, you add their exponents. All right, number 10. This one has the exponent on the outside. I have to distribute to everything inside. So the common error is they forget to distribute it through the 3. And they just leave it as a 3 here in the answer. And that blows it. I have to distribute it through all exponents. There's an exponent there, an exponent there, and an exponent there. Okay, so 3 cubed is 27. 3 times 3 times 3. And then I have 5 times 3, a power to a power. You need to remember when you're doing a power to a power, you multiply. This says I have x to the 5th 3 times, which then is x to the 15th. This one says I have y to the 8th 3 times. So that means I have 24 y's. Y to the 24th. Power to power, you multiply. All right, number 11, we're dividing monomials. Monomial means one term. Okay, all this is one term. Now, what I need to remember on this is negative exponents. I move down to the denominator, move to the other spot. If it's in the numerator, move to the denominator and make it positive. 9 over 45 simplifies to 1/5. And then I would have y squared in the numerator. That x cubed comes down. And I already have an x squared there, and I have a y to the 5th. Okay, then I ask myself, where do I have x's? Well, I only have them in the denominator, so I got to put an x down here. How many do I have? 3 plus 2 is 5 of them. That's why it's x to the 5th. Then I ask myself, where do I have more y's? I have more y's in the denominator. Well, how many more do I have? 5 minus 2 is 3, so I have 3 more y's in the denominator. And there's my answer, 1 over 5. X to the 5th y cubed. Number 12, a little more complicated. So we start with the easy one there. Now we get to a little more complicated. We see negative exponents on the outside, which means this whole thing in the numerator gets moved down there, and it's positive now, it's positive 2. And this whole thing in the denominator gets moved up here, and then that becomes positive 2. There's x squaring it up there. Okay, that's one way of doing it. Another way is I could just distribute the negative 2 through each of these right now. So if I did it that way, I'd have 8 to the negative 2. 3 times negative 2 is negative 6 for the x, and y to the negative 18. Then I distribute the negative 2 through this negative 2 through all of these exponents, and I have 3 to the negative 2, x to the negative 16, and y to the 8th, because negative 4 times negative 2 is positive 8. Okay, so I could start with this if I wanted to, and then I need to change all those negative exponents to positive by putting them in the opposite spots. So if I did that, this has to drop down to the denominator and become 8 squared. This has to go up to the numerator and become 3 squared. This is x to the 16th up here, and this becomes x to the 6th down there, positive. And then I have y to the 18th that comes down, and I already have a y to the positive 8. So now I have that situation. What is 3 squared? 9. What's 8 squared? 64. Where do I have more x's? In the numerator. So I put an x there. How many more do I have? 10 more. Where do I have the y's? They're all in the denominator. How many do I have total down there? 26. And there's my answer. Okay? So you got to know negative exponents, make them positive, drop them from the numerator to the denominator, or move them from the denominator up. It's the reciprocal. Negative exponent means reciprocal. Okay, let's see, up to 13. Multiply the following polynomials. We just got done doing this in class. I have 3x plus 3. Multiply just like elementary school. And of course, I just found out when I was going around helping people, there's at least one person that doesn't know how to multiply two numbers from elementary school. So if you have to, you better look up how to multiply 2 digits times 2 digits. 3 times negative 4 is negative 12. 3 times x is 3x. 3x times negative 4 is negative 12x. And 3x times x is 3x squared. Then I just add straight down. 3x squared. 3 minus 12 is negative 9x. And then I have my negative 12 there. Okay? Just like multiplying two numbers like 23 times 34 in elementary school, except for there's no carrying. You just write down the full answer for each one when you multiply those spots together. Okay. All right, 14 squared. Okay, you can do it again by multiplying by 6x plus 7 and do it like we just did up top there in 13. Or you memorize a shortcut I told you, which is to square the first term. That gives me the 36x squared. Multiply the two terms together, so 6x times 7 is 42x, and then I double that, so it becomes 84x. And then the last term is squaring the last term. 7 squared is 49. Okay, so that's a shortcut, but if you don't remember the shortcut, then you go ahead and work it out longhand and put 6x plus 7 down here, and I get my 49. I get my 42x, I get the next 42x, and I get the 36x squared. Okay, and then I get the same answer right there, long ways. Okay, now of course you're going to memorize, as I told you in class, memorize a shortcut, because if it's for extra credit points, it's so you can get the answer quickest. So those that know the shortcut are going to pop it out the quickest, unless they blow it. All right, the next shortcut is when the terms are the same, and the only difference is the plus and minus sign. When both terms in both binomials are the same, except for one plus and one minus, it wipes out the middle term. Remember I told you before, usually a binomial times a binomial gives you a trinomial, just like we got right there. Here's a binomial squared, it gives you a trinomial, that's normal. Here's a binomial times a binomial, it gives you the trinomial right there, 3 terms, that's what's normal. When you have the same terms, in this case 3x out of 5, 3x out of 5, and you only have a minus and a plus is the only difference. It wipes out the middle term. So I can just multiply the first terms together, 3x times 3x, that gives me the 9x squared. And multiply the second terms together. 5 times negative 5 is the negative 25. Okay, that's the shortcut. Otherwise, you work it out long ways and do the 3x plus 5 underneath and just go ahead and multiply it out and you will get 9x squared minus 25. Number 16, a trinomial times a trinomial. No different than a binomial times a binomial. I do the same steps. This is just like multiplying 123 times 465 or 64. I go through the same steps. I multiply the 4 through all these. I multiply the 6 through all these, and then I multiply the 4 through all those. Okay, that's exactly what I'm doing right here. Okay, so first I'm multiplying the 3 through all three of those. 3 times 9 is 27. 3 times negative 6 is negative 18x, and 3 times x squared, 3x squared is 9x squared. Next, I multiply this one through all three of those. Boom, boom, and boom. Negative 8x times 9 is negative 72x. Negative 8x times negative 6x is 48x squared. And negative 8x times 3x squared is negative 24x squared cubed. Okay, so there's a second row. Then I do the exact same thing again, multiplying the 7x squared through there. Okay, that didn't come out, but here you can see the 7x squared right there. Okay, so 7x squared times 9, 63x squared. Let's go on by that one. Now I go to the middle one. 7x squared times negative 6x is negative 42x cubed. Right there. Notice I'm lining up under like terms. And lastly, 7x squared times 3x squared is 21x to the fourth. Okay, just like multiplying hundreds times hundreds in the elementary school. Now I just add straight down. There's no other 21x to the fourth. That's why it's there. Add these two together. Remember, I only add the coefficients. So it's negative 66x cubed. Right there, the variable and the exponent stays the same when I add or subtract like terms. Again, I do this one now with the x squareds. Variable and exponent don't change, so it's x squared. I just deal with their coefficients. Add them all up, I get 120. Okay. Next, I deal with my x's. X to the first, coefficients, negative 90. And lastly, 27 is by itself. Constant goes at the end. Now that is in standard form. Highest degree down, 4, 3, 2, 1, and remember that constant is degree 0. I can always write that as x to the 0, which equals 1. All right, 17, another one. Except for I have three terms. I'm 3, and I'm multiplying s times the quantity s minus squared minus 6 times s plus 1. Multiplication is commutative, so that means 2 times 3 times 4 is the same thing as 4 times 2 times 3. So I can multiply in any order I want. That's the commutative property of multiplication. So a lot of people just go left to right, so I'll just do that. It doesn't matter though. I could have done s times this one first, got that answer, and then multiplied it by that. I would still get the same answer. But I'm just going to go left to right. So I multiply those together, and that gives me s cubed minus 6s. And then I've multiplied by the last one, s plus 1. You can never multiply all three together ever at the same time. 2 at a time only. 2, get that answer, and then that one times that one. Okay, so 1 times negative 6s, negative 6s. 1 times s cubed, s cubed. S times negative 6s is negative 6s squared. I squeeze that in between there because there's no other s squared there. And then s times s to the third is s to the fourth out front. Okay, so all these are individual terms. There's no like terms at all, so I just write them all out right there. Highest degree down, 4, 3, 2, 1. Okay. Number 18 is taking a binomial and cubing it. Now I got done telling you can only multiply 2 together at a time. So I did f minus 3 squared, and I used the shortcut rule. Remember the shortcut rule says I square the first term, multiply those together, it's negative 3f, double it, negative 6f, and then square the last term. Whenever you square a number, it's always positive. You better never have a negative there, plus 9. So now I take that answer and multiply it by f minus 3 again, right there. Okay, now I didn't have room to put that there, so that room that is put down right over here for 18. Okay, negative 3 times 9, negative 27. I'm just distributing this negative 3 through all three of these here. Negative 3 times negative 6f, 18f, that's an 8 there. Negative 3 times f squared is negative 3f squared. Then I go ahead and do this second row. Take this f and multiply it through all three of these. So that's 9f, again, underneath like terms, minus 6f squared, right there. That was the first one, the second one, and then f times f squared is f cubed. And just add down. And remember, when you add down, you do not change the variable or the exponent. So again, you got f cubed minus 6f squared. You're only dealing with the coefficients, plus 27f, that was an 18 there, and minus 27. Okay, and that's what you see right up here. All right, 19 and 20 are similar. It's just in function notation. That's the only difference. So let's take the f of x, which is that polynomial, and add it to the g of x, which is that one. So we just add those together. Well, notice I've already got that set up for you in like terms. So I can just add straight on down. So I get 5x squared. 2 minus 1 is 1x, and positive 3 right there. Remember, negative is positive 3, minus the 4 is negative 1. Okay, and 20, this just says to multiply the two, f times the g, f of x times the g of x. Okay, that's just one way you can write it. So now I'm going to multiply these two trinomials together. That's what I have right here. Okay, and then again, we just go right on through. Take the negative 4, distribute to all three of these. That's the first row right here. Then take the negative 1, distribute it to all three of these. Multiply to all three of these. That's row 2 right there. Then take the 3x squared, multiply it through all three of these. And that is the third row right there. Okay, and then I just add straight down because I already have my like terms there. And I get the final answer of this right here. Okay, so your test will be just like this. Okay, so I've got 20 problems. Be the same format, everything, just different numbers. So you can watch this over and over. You can practice the ones that you miss again and again until you get them right. Okay, you know everything that's coming. There's nothing tricky. You don't have to say, I wonder what else may be on the quiz or the test. Nothing. It's this right here. Now I might throw an extra credit problem on there, which I'm not going to tell you what it is, but there could be an extra credit problem. But that's it. All right, 23 minutes.